Hey guys, Mr. Milton here. Today we're going to talk about linear inequalities. At the end of this video you should be able to show all solutions to a linear inequality by graphing, and you should be able to explain what a solution to an inequality looks like. Remember from Unit 2 that we could solve inequalities in a different way. So the first inequalities we talked about looked more like this. X is greater than 4. We would place this on a number line, 4. We'd have an open circle to show that it's close to 4, but the solution did not include 4. And then we'd have an arrow pointing to the direction of the numbers greater than 4. Okay, and the reason we did this is to show that any number greater than 4, 5, 27, 6,124, all these numbers make this inequality true, and thus they are solutions to the inequality. Okay, an inequality has, I'll just say, infinitely many solutions. Not in the sense that it has any number works, but that a lot of numbers work. Okay, there are infinite numbers more than 4. There are infinite numbers less than 4. Okay, and which is why we need to graph to show all of them. Okay. All right. In the inequality above, how many variables does the inequality have? Well, it's just x. So 1. And what does the solution look like? It looks like any number. A number. Okay, so any of the numbers that I pointed out would be solutions. Today we'll be working with inequalities involving two variables, which means the solution will look like an ordered pair. Ordered pair. Okay. And so let's look at an inequality now. So we have y is greater than 1/2 x plus 3. So what we're going to do to graph this is we're going to treat this just like it has an equal sign at the beginning. So 3 is our y-intercept, 1, 2, 3. Our slope is 1/2. That means we'll go up 1 over 2, up 1 over 2, up 1 over 2. I can continue to do that. Down 1 over 2, down 1 over 2, down 1 over 2. Okay. So this is our line. Now the added complexity for inequalities is that we now need to consider this sign. Okay, and this sign is similar, has a similar job as it does in inequalities. These are the first inequalities we talked about. This sign tells us, is our solution, is our line or our border included in our solution? Okay, and so this says y is greater than or equal to. Because it's or equal to, it means the border is part of our solution. And so in the inequalities earlier, we would leave the circle open if it was not included and close it if it were. For our graphs, if it's included or equal to, that means it's going to be a solid line. Solid line. Okay. If it were not, we'd use a dotted line. Okay, and we'll see that later. Okay. And so it says y is greater than 1/2 x plus 3. Excuse me. So we can determine whether a point is a solution a couple different ways. The first way is we could plug in actually, let's do more than this. So y is greater than or equal to 1/2 x plus 3. We graph the line. Like I said, there's infinitely many solutions, and all the solutions don't lie on the line. Okay, this greater than means that it doesn't have to just be on the line. It could be anything that's more than the line. Greater than should make you think of above. And so now we shade. So similar to how we shaded our number line to the direction where our solutions were, we're going to shade our graph to the direction where those solutions are. Okay, and so it says determine if the given point is a solution to the inequality. We can do this by plugging in the values and seeing if it works out. So for 0, 0, I could plug in 0 is greater than 1/2 0 plus 3. And then 0 is greater than 3. Is 0 greater than 3? No. Okay, I could do the same thing with -2 and 7. So I'd say 7 is greater than or equal to 1/2 -2 plus 3. 1/2 times -2 is -1 plus 3 is 2. 7. Is 7 greater than or equal to 2? Yes. Do the same thing for 4, 5. 5 is greater than or equal to 1/2 4 plus 3. 1/2 times 4 is 2. 2 plus 3. Is 5 greater than or equal to 5? Yes. Okay. So that's one way that we can see if these points are solutions. Now there's a lot of different solutions, and another way that we could do this is we could plot these on the graph to see if it works out. Okay, so 0, 0. Where's that on the graph? It's here. Is 0, 0 a solution? No, it's not a solution because it's not shaded. -2, 7. I go -2, up 1, 2, 3, 4, 5, 6, 7. Is that a solution? Yes, because it's in the shaded area. 4, 5. 1, 2, 3, 4, 5. Sorry, 4. 1, 2, 3, 4, 5. Is that a solution? Yes, it's on the line, which is a part of the solution here because it's solid. Okay, so let's go through and fill in these blanks. You must make your line either solid, okay, and that happens if it's greater than or equal to or less than or equal to, or dotted, and that happens if it's greater than or less than. And this line separates the solutions from the other points. Say that. Okay, notice that none of the solutions are on this side of the line. It can't be. Okay, you must shade on one side of the line. The shaded region represents all the solutions to the inequality. Okay, and so you see there we could plug in numbers each time, or with our graph we can more easily, is 0, 0? No. -2, 7? Yes. 4, 5? Yes. Okay, allows us to see the solutions a lot easier. All right, flipping to the back side. To determine which side to shade, you must have your inequality in slope-intercept form. Say y equals mx plus b. That's slope-intercept form. Okay. If the symbol is greater than, so we'll say greater than or equal to, then you shade above. If the symbol is less than, so less than or equal to, then you shade below. Okay, so let's look at this one. Y is greater than -2/3 x plus 7. Our y-intercept is 7. 1, 2, 3, 4, 5, 6, 7. -2/3, so I'll go down 2, right 3. Down 2, 1, 2, 3. Okay. Our sign here is greater than. It does not say or equal to. So we will dot our line to show that, hey, this is the border, but it's not a part of the solution. Okay? And because it's greater than, we will shade above. Now, this problem says give just one solution to this inequality. That's any point over here, any point in the shaded region. So I'll give a point of 3, 1, 2, 3, 4, 5, 6, 3, 6. 3, 6 is a solution to the graph, or to the inequality, because it's in the shaded region. Okay, there's a bunch of answers to that as well. So any other point in the shaded region works. In our second line, we have y is less than or equal to 5x minus 1. So minus 1, 5x, our slope is 5. That means I'll go up 5, 1, 2, 3, 4, 5, and to the right 1. I could also go down 5, 1, 2, 3, 4, 5, and to the left 1. Okay. Our line is or equal to, so I know it's solid. And it's less than, so I shade below. Now, with the more vertical a line gets, the more difficulty students usually get with where to shade. So, shade below, always just pick a point, drag it down. Okay, I'm going to shade on that side. Okay, all the solutions have to be on the same side, up or down. Okay, and now I have to pick a solution, anything over here, so I'll just say, sure, 2, 0. That point. Okay, now these two problems were really nice because they were already in slope-intercept form for us. We might have to, well, looking at 3 and 4, what do you have to do first for these? Well, you need to convert to slope-intercept form. Okay, or in other words, solve for y. Okay, so I want to solve for y so I can graph this. 4x plus 3y is greater than or equal to 9. I'm going to subtract 4x from both sides. So I have 3y is greater than or equal to negative 4x plus 9. And then I'll divide by 3. And so when I do that, I have y is greater than or equal to negative 4/3 x plus 3. Let's graph that out now so I can see my problem. Alright, and so now we can graph this. I'll try to set this up so it's in the middle. Sorry, guys. Okay, now we can graph this. So my y-intercept is 3, 1, 2, 3. My slope is negative 4/3, 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Okay, is my line is solid because it's or equals to greater than or equal to. Oops. Okay, so or equal to means solid line, and then greater than or equal to means that we're going to shade above. So we shade above, shade above. Okay, and now the question, is 3, negative 1 a solution? 1, 2, 3, negative 1. Alright, it's on the line. Is 3, negative 1 a solution? Yes, the line is solid, so it is a solution. If the line was dotted, it would not be a solution. Okay. Let's do y together, or number 4 together, the last one. Okay. So for this one, I'm going to subtract 4x from both sides. I'll start it up here because I was a little bit tight on space for the other one. When I subtract 4x from both sides, I'm left with negative 6y is greater than negative 4x plus 24. Now I had to get y all the way by itself, so I'm going to divide by negative 6. Remember with inequalities, when you multiply or divide by a negative number, you have to flip the sign. So we have y now is less than negative 4 divided by negative 6 will give us positive, and I'll just simplify here, 2/3 x minus 4. So minus 4 is our y-intercept, 1, 2, 3, 4. 2/3 is my slope, up 2 over 3, up 2 over 3, 1, 2, 3. Do that right? Yep. Or I could go down 2, left 3. Now, my line, it's less than, it's not or equal to, so it's going to be a dotted line. Try to keep the straight edge down. Dot it, dot it. Okay. And then it's less than, so I shade below the line. So I'm going to shade below the line. And so now the question, 6, 0. Is this a solution? 1, 2, 3, 4, 5, 6. It is on our line. It is on our dotted line, so no. Alright, So that is solving systems, or solving systems of linear inequalities. Or sorry, not systems yet. This is solving linear inequalities. A little foreshadowing for the next lesson. Um, Hopefully now you're able to graph linear inequalities, identify the solutions, and tell what a solution looks like. All right, see ya.